We're going to start with just a couple problems out of section 8.2. It's just about being able to read the t-table, so it's not that bad. And then we will do a couple of examples from 8.3 using this information. Okay, so this one says consider the value of t such that 0.025 of the area under the curve is to the right of t. And this is telling us that the area is to the right of our t value, so we're going to pick the picture where we're shaded to the on the right side. Okay. So the area is to the right of t. So then it's going to ask us to find the value of t, assuming the degrees of freedom equals 25. Okay, so for degrees of freedom equal to 25, that's this row. And we've got 0.025 of the area to the right of t, so that's going to be this middle column. So 25 degrees of freedom, this middle column, we will get our t value. Okay, 2.060 would be our t value here. Since the area was to the right of t, okay, then that means we're going to have positive. If it was over on the left side of the curve, it's like the normal curve. Values on the left side would be negative, so you just change it, the sign to negative. Let's do one more here similar to that. So we've got, that's to the right again. Let's do one to the other side. It's to the right. Let's do one to the left. So we've got 0.05 of the area to the left of t. So we'll pick the one that's shaded to the left. And then it says we can assume we have 24 degrees of freedom. So we've got 0.05 of the area in the tail. So that's the second column. We want 24 degrees of freedom. So it gives us 1.711. But again, since this is over on the left side, these are going to be negative values. Zero's in the middle, so the left side's negative, right side's positive. So on the left, so we get a negative here. And then we got one more that's a little different. Let's skip ahead to it. There we go. This is a good one. So this one says, consider the value of t such as the area to the left of negative absolute value of t plus the area to the right of absolute value of t equals 0.1. So this is area in both tails together is what this is giving us. So this is going to be the one shaded in the two tails. Okay. So part of it's on the left side, part of it's on the right side. So then when we're finding the t value here, we have to be a little careful. And because it tells us we have an area of 0.1 in both tails, this particular table, it gives us the area in one tail. Later in the next section, when you go to the t-tables, you can pick, do you want it to be area in one tail or two tails? And we'll look at that in the next section. But for right now, this table that's popping up is giving us area in one tail. So if we do 0.1 divided by 2 to figure out how much area is in one tail, we're going to figure out we have an area of 0.05 in this column in one tail. And then we want 8 degrees of freedom. So 8 degrees of freedom. There we go. And then it's kind of a little tricky here, but since it gives us a positive t, we're going to give the positive answer here. So 1.860. So not too bad, just getting used to using the table. And the thing to realize is that this one that pops up, these areas up here across the top represent the area in only one tail. So if you have one of these that gives you the area in two tails, you need to divide that by 2. You won't necessarily have to do that in the next section though. Okay. So let's look at a couple of confidence interval problems then. So these are really similar to the ones from the problems from 8.1. And the only difference is that we're using a critical t value instead of a critical z. Okay, so this one says a student records a repair cost for 8 randomly selected TVs, a sample mean of $64.05, and standard deviation of 28.66 are subsequently computed. Determine the 90% confidence interval. Okay, so just like before, we have to have a starting point to make one of these interval estimates, and our starting point is going to be our sample mean. Okay. So here the first number we're concerned about is our sample mean, x bar. And on this problem, that is $64.05. Then, once we have our starting point, our point estimate, we need to figure out a margin of error to figure out how far above and below our starting point we need to go for our estimate. Okay, so our margin of error formula here, this one does not give us population standard deviation. Okay, this standard deviation that it gives us comes from the sample data. This is different than 8.1. So this standard deviation here is S, sample standard deviation. Okay, so our margin of error formula here, let me rewrite that E, it's kind of messy. That's still messy. Is we have a critical T value, T sub alpha over 2, times S, the sample standard deviation, divided by the square root of N. So we need a critical T, we need our sample standard deviation, and we need our sample size. Okay, so we've got S already, 28.66. Our N, our sample size, is 8 here. Okay, so we've got that. The only other piece of information we're missing is this critical T value. To look up critical T value, we need to figure out two things. We need to figure out degrees of freedom, DF. That's the first one, and the way we get that is N minus 1, so sample size minus 1. So here we're going to have 7 degrees of freedom. Our sample size was 8. Track 1, we get 7 degrees of freedom. And then we need to know something about the area and the tails. And to me, on confidence intervals, it's easier to do it with the area and 2 tails. Just that's one less operation we have to do. We don't have to divide by 2. And the way we figure that out is we look at the confidence level. Sorry, I don't know if you could hear that or not, but I think the FedEx man came and the dog was losing his mind, so I had to pause for a second. I think we were saying that we want to calculate the area and the tails here, and to me it's easier to do it in 2 tails. The way we figure out the area and the tails is we look at the confidence level. Okay? Confidence is the area in the middle of the curve. So if we do 1 minus our 90% confidence, or 0.9, 90%, then that tells us that we've got 0.1, or 10% of the area in 2 tails. Okay? So we want the critical T value with 7 degrees of freedom and 0.1 in the area in 2 tails. Okay? So that will give us our critical T. So we can go to the tables in Hawks, and these are the tables I'm talking about. So let me get this problem out of the way. Okay, so we go to the T table, and here I'm doing area in 2 tails just to save us a step. Okay? So in 2 tails, we said our area was 0.1, and we wanted 7 degrees of freedom. So our critical T value is 1.895. With these confidence intervals, you're never going to have a negative critical T. So it's always going to be positive on these problems. That's one less thing to think about. So our critical T value for our margin of error is 1.895. Okay, so that came from our degrees of freedom, and we did 1 minus the confidence level we want. So 1.895 here. So critical T, 1.895. We already have the other numbers we need. And now we can plug into our margin of error formula. That's 1.895 times our sample standard deviation, $28.66, divided by the square root of our sample size, not degrees of freedom, but our sample size. So our sample size was 8. And then it tells us to round the 3 decimal places, so we'll do that. Okay. So 1.895 times 28.66 divided by the square root of 8. Here I'm getting rounded to 3 decimal places. I'm getting 19.20, and it rounds up to 2. So that's my margin of error. Okay. So now, just like before, now we're into old territory. Okay, we're going to take our margin of error, our point estimate, sorry, our sample mean, and our margin of error. We're going to figure out our interval. Okay, so we'll do that by doing x bar plus e and x bar minus e to get our upper and lower endpoints. So we'll do, for the upper endpoint, we'll do 64.05 plus 19.202. Figure that out, and then we'll do 64.05 minus 19.202. And we're going to round. I don't have the instructions pulled up, but on the next step, it's going to tell us to round to 1 decimal place. 64.05 plus 19.202 gives us 83.3 when we round. For our upper endpoint, 64.05 minus 19.202 will give us 44.8 for our lower endpoint. Okay. So those would be our two answers on step 2. These are our step 2 answers. And all it asked for on step 1 was this margin of error. So that'll be our answer on step 1. Okay. We're finished with that one. Okay, let's look at one more. Okay, these are all really similar. The only thing that really changes are the numbers and what part of the table you use to get the critical T value. This one says, in a random sample of 11 residents of the state of New York, the mean waste recycled per person per day was 1 pound, with a standard deviation of 0.77 pounds. Determine the 80% confidence interval for the mean waste recycled per person per day. Okay, so again, we're going to start off with our important starting point, which is the mean. So it says the mean waste recycled per person per day was 1 pound. X bar, our sample mean, is 1, and we'll keep it 1.0 since it gave us a decimal place. So then the thing we need to make our interval estimate is a margin of error. We need a critical T value, sample standard deviation, and the sample size. We can get 2 of those from the problem. Our sample size is 11 residents. Our sample standard deviation is 0.77. The other thing we need, or the other information we need to be able to figure out our critical T value is degrees of freedom. And then the area and the tail. So degrees of freedom, that's n minus 1. Our sample size is 11. So we have 10 degrees of freedom. And then to figure out the area and the tails, we do 1 minus the confidence. So the area in 2 tails we want the area in 2 tails, it's 1 minus 80%, or 1 minus 0.8. So we get an area of 0.2 in 2 tails. So then we can use that information to go to the T table and figure out our critical T value. So 10 degrees of freedom, 0.2 in 2 tails. So when we go down to our tables, and I will print these tables and give those to you. So we had 10 degrees of freedom, so that's this row. And then we wanted an area of 0.2 in 2 tails. So that means our 0.2 up here. Be careful not to get 0.02, 0.2. So our critical T value is 1.372. And that's from the critical T table. And 1.372. So now we can fill in, figure out our margin of error. That's 1.372 times our standard deviation was 0.77 divided by the square root of our sample size, which was 11. And it says we can round to 3 decimal places, so we will. So 1.372 times 0.77 divided by the square root of 11. We round to 3 decimal places. This one rounds to 0.31, and then the last digit rounds up to 9. So this is our step 1 answer, our margin of error. On step 2, it's going to ask us to make the confidence interval. So we'll do that by taking our sample mean, 1.0, and adding and subtracting our margin of error, 0.319. So for the upper endpoint, we'll add. For the lower endpoint, we'll subtract. Let's subtract. And this one's pretty easy to do since our sample mean was easy. So, and then on step 2, it'll say we can round to 1 decimal place. So this one, when we add, we'll get 1.319, but it'll round to 1.3. Right, that we rounded. And then when we subtract 1 minus 0.319, we get 0.681. That would round to 0.7. So that would be our upper and our lower endpoints for our confidence interval. So really similar to 8.1, except this part of getting the critical t-value. That part's just a little bit different. 8.4 is going to be really similar to these also, just instead of using 8.4, instead of using a sample mean, we're going to use something else called a proportion. Okay, let me know if you have any questions.